So in this particular lesson, we are going to discuss SAML. SAML is one of the first ways to implement single sign-on in corporate environments. Even today, it is used for single sign-on. But these days, OIDC has taken over SAML quite a lot, but still SAML is being used a lot. And it is one of the important topics. And if you understand SAML, OIDC will be very simple and straightforward for you because it's more or less the same thing. So let's get in the SAML part. First, we will see the theory part of it, the flow part of it. Most of the flows are going to be the difficult part in understanding something like SAML. After that, we'll see a solid demo on SAML using AWS and Azure. So one of the very important topic to pay attention, and the demo itself is a very valuable demo. You can get even a job just by doing this particular demo. So pay attention and let's have a look into the topic. Thank you. So SAML, or Security Assertion Markup Language. If you have understood everything so far, especially the RSA and the verification of the signature, digital signature in general, is nothing but DS, digital signature. You will have no difficulty with SAML. If you have understood everything so far, what we have discussed, you have no difficulty understanding SAML. SAML, I would say, something like MTLS on steroids with more bells and whistles, so that the overhead of MTLS is considerably reduced. So what is the purpose of SAML? The purpose of SAML is single sign-on, or SSO. That's the most common use case of SAML. But it is used in a lot of different scenarios, especially in the case of identity providers like Entra ID, which is Azure Active Directory, which we will see in the example we are going to look at. Another is Okta, ForgeRock, different relatively new identity providers. In fact, the so-called OIDC, conceptually is exactly same as SAML, just that slightly different format and things like that. Just at the end of the day, same wine in a slightly different bottle, no difference whatsoever. Now, that's enough introduction. Let's see what this is all about. SAML is an authentication mechanism. Also, it is used for authorization as well, especially that's the example we are going to see, authorization and authentication using SAML. Basically, it is used instead of username and password at different places. That's what SAML is all about. We have seen different options for username and password. For example, QR code, multi-factor authentication like OTP, certain apps, multi-factor authentication app, Face ID, fingerprints. SAML is similar to that, but in a slightly different way. It is more like the cookie we've been seeing so far in the case of Gmail. Now, the first person is in the SAML workflow is the end user. So that is the first user or entity of this particular workflow. So user with a browser like Chrome or Firefox, whatever it is. Now, the second one is the service. It's a Gmail. By the way, Gmail doesn't use SAML in that traditional format. It is using something like OIDC, but it is pretty much the same concept at the end of the day, at least similar concept. Let's say Gmail using SAML or any other service where you have some data, where you have some secret private information. That is what I call service, where you need authentication. So this is a service, just like the case of that EC2 instance role we have provided inside the AWS console. So that's a service which needed authentication. Now, what is the final piece of the puzzle? Which is the IDP. What is IDP? IDP is nothing but the identity provider. There is a lot of different pet names for this guy. But ultimately, this guy is the guy who can verify a username and password and provide a SAML token. Now, there are so many different workflows. One is service initiated SAML. Another is user initiated SAML. Doesn't matter which way, it all does the same thing. So this direction is time. It's like a sequence diagram we are going to draw, which is kind of typical in terms of SAML. So time is progressing in this direction. So what happens? First, let's say we are trying to access Gmail. You have typed mail.google.com in your browser. Now, what the service is checking? Service will check if you have something called SAML token. We don't know what is SAML token yet. It'll check for a particular number, just like the case of the cookie. No difference. It's all same thing, guys. It's absolutely same thing. No difference. They call it different names, cookies, SAML. It's all depends on that private key and public key, which we will see. So it checks for the number, which is SAML token in this case. And the number is not present. What will happen? You will get a HTTP 301 or 302 or something like that. Basically a redirect. The response is going to be a redirect to what? To the IDP. So this is going to the IDP. That's why I'm going this particular semicircle here. This means that it is not touching the Gmail. The semicircle right here, it's jumping. It is directly going, the browser is directly going to the IDP, the identity provider. So in the 301 redirection, Gmail has told the browser, hey, you don't have the SAML token. Go and get it from your IDP. And this is the URL of the IDP. Let's say this is account.google.com. Let's say that is the IDP. Now you reach the IDP. What happens? IDP responds again with the semicircle here. Responds with the web page. What is this web page is all about? Username and password. IDP asks the username and password. Now you type the username and password and all sorts of things like multi-factor authentication, fingerprint, whatnot, OTP, everything, whatever this IDP wants. Your task as a user is to make this IDP happy and get the SAML token, which we are going to discuss next. Now, there could be a different level of back and forth between these two parties until the authentication is successful. It can be anything, any levels of authentication. Could be multi-factor, could be OTP, could be something different. But as soon as the authentication is done, so the user has given all the required things and the authentication is successful, what the user gets is something called a SAML token. It's a SAML token or SAML response. So many different names for this particular number. Again, it's a number, and this number is all about, it's an XML file at the end of the day, but it has the signature of this particular IDP. The signature by this IDP, just like the case of a trusted root certificate. IDP has signed this particular SAML token. There is a signature. So you can verify who has signed it. And in the signature information, whatever username you have given here, say XYZ, that information is also present in the SAML token. Basically, it is kind of giving you a certificate. It doesn't have the public key and all those certificate related data, but it has a signature with a lot of metadata. You are really what you are claiming to be by the IDP signature. And who trusts this IDP signature? This guy right here. This guy has configured to trust only this IDP, not all the root certificate in the whole world. It has specifically configured to trust only this IDP's public key. Very important. We'll see all this thing in our practical, but understanding the concept is more important. So this is the critical step right here. Let me draw that in a different color. So obtaining the SAML token. So we are giving the username and password right here. All the required authentication information we are giving to the IDP. Password, fingerprint, face ID, everything we are giving. What is the thing IDP is giving? A SAML token. SAML token has a lot of limitations, like it is valid only for a certain period of time. Now, what is the use of the SAML token? We got the SAML token here. So this is the SAML token in the browser. Now, this SAML token is with the browser. Now that SAML token can be used to authenticate to a multiple different places. One example is this. Now, next request you're doing is to this guy. By the way, this is all between the IDP and the browser directly. So this guy is not present. So let me draw the semicircle here. So this part is not there. So I'm just erasing it. It's very important that part is to be erased. That's why I'm putting a lot of effort to erase it. So when the client is connecting to the IDP, the actual service is out of the picture. Very important point to notice. The actual service is this. It is out of the picture. Very important point to notice in terms of SAML, OIDC, pretty much all this kind of authentication mechanisms, right? So let's get back. Once you got the SAML token, what we're going to do? We're going to pass it to the service, which is Gmail in this case. And Gmail is happy because Gmail trusts this IDP. The big question, whether Gmail connects to IDP to verify the token? No. Very important. There is a complete no here. Gmail doesn't connect to the IDP to verify this token is valid or not. Why? Because the service can verify just by the public key of the IDP. Just like in the case of certificate. Because it's a digital signature within the SAML token. If you have any kind of confusion, feel free to refer to this again, repeat whatever you like. So the main point is that after the authentication from the IDP, so IDP is accounts.google.com, what we are getting from the IDP? See, SAML token, right? From the SAML token, we are redirecting further. So along with the SAML token, so this is essentially a 302. We'll see all this HTTP code in the fiddler when we do this in practice, in the demo. We are getting a 302 with the SAML response. This is called a SAML response. So there is SAML request response, all these things. But what matters to us is SAML response. So in the SAML response, we have the signature. So something has been encrypted using the private key of this particular IDP, of which public key is trusted by the service. Now, the Gmail will allow access and give the mails, give all the private information to the user. Now, the story doesn't end there. Why? The reason is there could be other service as well. Let's draw another one, a different service altogether. Say Google Maps. So this is a Google Maps. This is calendar. Pretty much all the services from Google. Now, all these guys trust this identity provider, which is accounts.google.com, is trusted by all these guys. Because of that, you can use the same SAML token to authenticate to all these services. For example, when you want to use map, what you can do, you can just take this token, it's already there with you, and send the request directly to maps. So this is all jumping here. It's all semicircle. It's not touching anywhere. Directly going to maps, and map will respond successfully with a 200 because you have a valid SAML token which is trusted by maps. This IDP is trusted by maps. This IDP is trusted by calendar or whatever other Google services you are using. One thing worth mentioning, Google doesn't use SAML per se. SAML is just an XML format, but it just does the exact same thing at the end of the day, more or less. Just that the format in which these things are done is slightly different, that's all. So that is what the core working of SAML. There are different names like SAML request, SAML response, SAML assertion, all these jargons they use to confuse people, but at the end of the day, it is just RSA algorithm behind the scenes. So a couple of main points. IDP never connects with the service. There is no connection between, there is no network connection between IDP and the service. Very important. So IDP is standalone, but the public certificate of the IDP is trusted by these guys. That's how it is achieved. Now we are going to see a live example of this whole workflow. It is slightly complicated. So if you want to watch this again, feel free to do that. I will erase this diagram and I will draw a little more concrete diagram. So we are not using Gmail or Google Maps or anything like that, because that is not an example of SAML. SAML is in fact used a lot in the corporate environment within the intranet of a company. But nothing stops SAML being used in the internet. It has no security issues whatsoever that way. But it is mostly used internally, while OIDs is more common. For example, something which Gmail uses. Apart from that detail, let's draw a concrete diagram of the demo which we are going to do. Pretty much it will look the same, but let's see how it's done. So in this case, we have the user here, the end user, which is me. This is me sitting here. We'll be using a couple of different browsers, Edge, Chrome. We won't be using Firefox, I guess, for this particular exercise. Let's see. Now what we're going to do is that we have the AWS. AWS is our service. And what is our IDP? Our IDP is Microsoft Entra ID or Azure Active Directory. Azure Entra ID. That is our IDP. Completely different world. This is Amazon Web Services, completely different company, completely different environment. This is Microsoft, Azure, everything is in Azure. Again, public, no relation whatsoever. And again, we are going to use public network for every single transaction. There is no internal network, which means what I can see can be seen by the whole world, technically speaking. So there is an Eve sitting everywhere. So this is the boundary. There is Eve everywhere. Eve can see all these traffic. So all the communication happens through the public network. So this is internet, which is public. All right. So that's the use case we are going to have. Now our service is AWS and our identity provider is Microsoft Entra ID. Now what are the steps we are going to perform? So let's discuss that. So first we are going to create a user inside Azure Active Directory. Before that, we need to onboard something called a domain. I'll show you how to onboard a domain into Azure Active Directory after setting up everything, because I have already onboarded a domain. So I want to use that for this particular demo. Onboarding a domain is not very difficult. We have already seen that in one of the examples when we generated that certificate. It's exactly the same process, just putting a particular record in the DNS. We have seen that. So I don't want to focus because this demo is already slightly complicated. So I don't want to complicate it further. So in the custom domain, so we have a custom domain inside Azure Active Directory. In that, what we are going to do, we are going to create a user. So there's a user getting created here in the custom domain. So that's the first thing we are going to do, creating a user. After that, what we are going to do is that we are onboarding an application. AWS. AWS is an application. It's like any other service for Azure Active Directory or Entra ID, which is our IDP in this case. So we are onboarding this particular service and we are setting up all the URLs and things, where to go, where is a SAML request to be sent, all that kind of details we are going to put it here so that all the redirections will work correctly. Now, if we were doing only this much, the authentication will work. But in our case, we have to do the authorization as well. For that, what we need to do is we need to create a role inside the AWS. There is a role. We are going to create a role inside AWS, as well as we are going to create an identity provider, IDP. We are going to onboard this particular IDP into the AWS. There's no connection again. Let me not draw that arrow. Let me remove that arrow because there is no connection. There is no network connection. Basically, we are telling AWS, hey, you need to trust the public key of this guy. That's all we are saying at the end of the day. So that's how we are configuring the IDP inside AWS. Now we are creating certain policies here in the AWS policies. The policies are basically to give permission to the AWS to read these roles so that the role-based access control will work as well. So in the SAML token, you can mention what are the permission this user should have. Remember, I was talking about SAML can be used for authentication as well as authorization. So along with the username, you can mention the role name of the user as well, along with the other details like the signature and things like that. So we'll see that in the SAML token. But these things right here, let me draw that in a different color. One is this, another is this, and a couple of things here as well we'll see. A couple of configuration we are doing because we need to select this role from here, etc. Those are done for authorization. So that is for authorization. We are adding some additional attributes inside the SAML to tell AWS after the authentication that this particular belongs to this particular role. Now these are the things we are going to create. Now let's go through the workflow of this whole thing. So let me remove a couple of stuff here. Now in our example, we are going to look at the IDP initiated workflow, which is in this case myapps.microsoft.com. So if you don't know what this is, nothing to worry. This is a place where all the Entra ID applications present. We'll see what is Entra ID application, but it's at the end of the day just a web page where all the SAML things works. That's all. Now the user, which is me in this case, going to go into this particular URL, myapp.microsoft.com. Now what happens? Of course it is microsoft.com. So it'll ask for authentication. It goes straight here. Once I'm authenticated, I give all the username, password, OTP, whatnot. It gives me a page like this where it shows all the application which I can access within my domain, within the domain. Now what I'm going to do, there is AWS here, my AWS app here, which is onboarded in the Entra ID. Now what I'm going to do, I'm going to click on that. Now one thing we need to understand here is that the moment we have a successful login, we get the SAML token. The SAML response is right here and it is already present here. Now all these applications you are seeing here can use this particular token. Let me draw that token in a different color again. So this is the token. This orange is the token. Now this token can be used for all these applications at the end of the day. That's why this application is shown in this particular page right here. Now what? I'm going to click on AWS. It's no different from anything else. The token will be given to that thing, which is here. The token will go to the AWS like this, and the AWS will return all the required things. Now, one thing which is there in this particular token is, one is the username. Another is a role of this particular user. Two things are there. So role is an additional SAML attribute we are passing, which we have configured inside the IDP. So normally all the IDPs manages these days the role-based access control of the user as well, along with identity. So identity is one thing, which is the authentication, and the role, which is the authorization. So normally these IDPs right here, they does both authentication and authorization. And in this case, we are going to get that user and we can do whatever this particular role allows us to do. Now let's set all these things up. So there is a little bit of steps involved. I'll walk you through it. It's kind of a production level setup we are going to do, but SAML is always like that. There is no easy way to demonstrate SAML otherwise. So what we are going to see is a kind of an important demo which is used in almost all the organizations which I have worked for. Entra ID usage. You can make a living just with the next demo because that's a very hot skill in the market. So pay attention to the demo, and if you have 2 accounts, you can do it as well. You need to have a domain as well. I will show you that bit in the end. I'll start with an onboarded domain, dev.sourcelens.com, but I will show you how to onboard a domain into Azure Active Directory. If you have any questions, ask me. There's not a lot of reference in the internet. There's a lot of documentation, but there is no videos available for this particular demo. Now let's get into the demo straight away. So we are inside the Azure portal, the Azure Cloud portal, portal.azure.com. So if you go to the custom domains, if you want, you can search for custom domains. You can see that there are 2 domains. One is this default domain which comes, and there is a custom domain I have onboarded, dev.sourcelens.com.au. So this is onboarded using the same technique we have been using so far, adding a particular DNS entry. Remember when we generated that certificate using AWS ACM certificate manager, we added that particular entry and got a certificate generated. Similar to that, same process here. I'll show you that in the end, but we have onboarded a custom domain, custom DNS name to the Azure Active Directory. So we'll be doing everything in this particular domain from now onwards. First, what we are going to do is to create a user in this domain. So that's what we are going to do. We are going to create a user in this particular domain. So when we say domain, does it mean that the traditional Active Directory domain, if anyone is wondering from the Active Directory background, if anyone is there, yes and no. You can use it as an Azure Active Directory domain, as a AD domain as well, but it doesn't have the traditional way of domain controllers. At least in the demo we are going to see. You can have such kind of domain controllers as well within the domain. That's a different thing altogether, but for the time being, it is not a traditional domain that way. It is behaving like an identity provider. It's kind of a expert note here. You don't have to worry if you don't understand what I'm saying. But otherwise, what we are going to do is we are going to create a user. So we have clicked on the domain and we have gone to the users. That's where we are. And we are going to create an user. We are just giving the username. As you can see here, there are different domains on the right side. If you drop down, as you can see, there is different domains. All the domain you have onboarded, you will be able to see, and you can create a user in different domain. As you can see, create a new internal user in your organization. That's what we are trying to do. You can come directly to this page once you have onboarded the domain, create new user. You can type it here, create new user, and you will be in this page if you're doing this demo by yourself. But we have to select the dev.sourcelens.com in this case. That's what we are doing. That's the domain we are creating the user. And again, usual display name and password and things like that. Enabled, auto-generated, all these things. In this case, we'll change the password once it is created in the first logon. Right now, I'm just giving a test password. So this is the password. If you want to have a look, we will change it later. Next, some of the properties. Some are optional. A lot of these things you can simply leave it as it is. I'm going to click next and create. Create. I don't want to save anything. What I'm going to do is I'm going to refresh this particular page and the user has created. As you can see, the user has come here. So this user is in a different domain. As you can see, the domain is different. This first user, Anand George, that user is the root user of this particular account, this Azure account. And this is the user we have just created, and that is in the dev.sourcelens.com. Now what we are going to do is we are going to go to the Entra ID, the Microsoft Entra ID. Click on Entra ID, or you can type. So all the things, users, groups, external identity, roles, and administrator, everything is here. It is looking pretty similar to that IAM thingy we have seen. Not much difference. As you can see, all the role-based access control mechanisms looks very similar. Even the names looks very similar, as you can see, with slight differences. Although it is completely different cloud providers, look at the similarity. Look at the adherence to the theory we've been discussing so far. That's a point worth noting here. I'm going to click on Enterprise Applications, New Application. And in this case, what we need is AWS. Basically, AWS single sign-on access. Couple of setups we are going to do here. Basically, onboarding AWS into this particular Entra ID as an application. AWS Test App, that is the application name we are creating. As you can see, a lot of these things are pre-populated. All the URLs and things are pre-populated. So there are a couple of things here, the application ID, object ID. Some of these cases it will be useful. But in this case, we are going to leave all this as default. So I'm going to click on Enterprise Application on the top and going to refresh so that I'll see the application created. So this is the new application has created, the Enterprise Application. So basically, we have onboarded the AWS application into Azure Active Directory. Basically, you can add any number of applications to Azure Active Directory, AWS being one of them. Now we have to make some configuration changes, mainly single sign-on, clicking on single sign-on, SAML, and some of the changes we need to make on the default. So this is the ID here. We can pretty much put any ID we want. So I'm just going to put a 1 here. All good. That doesn't matter. And I'm going to save everything else as default. So now, one thing worth mentioning here is the reply URL. Let me annotate that for you. So this is the reply URL right here. And this URL is important. This is a URL to which the SAML assertion will be posted. We'll see this URL again in the fiddler. But remember, this is a URL. We are going to push the SAML assertion. Whenever there is a SAML request coming, if it is Amazon, AWS, this is the URL we will be using. So it's a generic URL for all the SAML assertion for Amazon Web Services. Remember, Amazon Web Services here is just a service. It's a scapegoat service we are trying to target, which has a proper identity and access management system. That's all AWS is all about here. It could be anything. It can be Salesforce. It can be GCP. It can be SAP. Any enterprise application will do, which accepts a SAML token. Any internal application, anything can be configured like this. And they will have a different URL where that application accepts the SAML token as part of the authentication into that application. Very important to understand this particular piece. So this is our URL where you push your SAML token. Assertion consumer service URL kind of means okay to me, but not the most intuitive name. Assertion consumer service URL. We'll see it again. Till then, let's continue. Now there are a couple of details here. One of the things you can do is to look at the certificate, the base 64 certificate. We'll look at that certificate later. Let's get this done first, and let's make sure that things are working before we start explaining and dealing with a bit of theory. We'll come back to all these things later. Let's get this setup finished because it has its own complication and we need to focus on what we are doing rather than going into too much explanation. Let's focus on the procedure part for the time being. What we are going to do is that we are going to download this particular metadata XML. So basically what this XML is all about is the details of the IDP. Now this is the thing which we are going to import it into the AWS. Basically asking the AWS to trust the signature coming from Azure. Trust the public key of Azure. That is what this XML is gonna tell. we are going to import this XML into the identity provider within AWS. Very important. Federated identity provider. That's the pet name for this SAML. Whenever you see the word federated, they're talking about SAML. They are talking about the signatures inside the SAML token. It's all just business jargons and buzzwords out there, federated, but it's all RSA algorithm. Now, what we are going to do, we are going to download this thing and import it into AWS. So this is a quick look at the file. Again, it's an XML file and it has a certificate, all that kind of things. If you want, you can decrypt the certificate and look at it, but we will see that slightly later. Mainly, it has a certificate. That's the main information within it. There are a couple of other information as well. Basically, it is the details of the IDP itself. Now, we are in our AWS console. Now, what we need to do inside the AWS, we need to import our IDP. So we need to tell the service that we are going to have a identity provider. What is an identity provider? Identity provider is the guy who can verify a username and password or provide multi-factor authentication like Okta, Ping, ForgeRock, and obviously in our case, Microsoft Entra ID. And in this case, as you can see, there are two guys here, SAML and OpenID Connect. Let's have a quick read. Establish trust between your AWS account and a SAML 2.0 compatible identity provider such as this thing. I don't know how to read that. It is a product similar to the one we have discussed. No magic, nothing. There are hundreds of products out there which does this. And Active Directory Federation service, which is nothing but our Entra ID, the new pet name. Another is OpenID Connect. Establish trust between your AWS account and identity provider service such as Google and Salesforce. They use similar thing in a different bottle. At the end of the day, it is one and the same thing. Just different file formats, that's all. Now we are continuing with SAML because that's what we are going to use. We are simply naming it Azure AD and choose the file. This is the metadata document which we downloaded and we are opening here, and that has all the required information for the provider. And we are going to click on add provider and the provider has been added. Now onwards, AWS is going to trust the signature. That's what we have done, identity provider. Now what we're going to do, we are going to create a role, and in the case of role, unlike last time, we are going to create a SAML Federation Trust Entity type. Very important to understand. Previously, we have selected AWS account because we were planning to trust an AWS IAM user. But in this case, we are not going to do that. Whom we are going to trust? We are going to trust a SAML Federation. Basically, a public key we are going to trust. And whatever comes through that public key, we will allow to assume that role. Very important point to understand here. So we are going to trust an external SAML provider, a public key, to assume a role. We have added the identity provider. Now we are telling this particular role to trust that identity provider. Now let's continue. Azure AD, that's the only identity provider we have. We are giving all the access, programming access and management console. Now, as usual, add permission. Now, once you trust that user, what that user can do, that is this permission all about. So again, typical role-based access control is in play. If you have any question, feel free to refer to the previous videos. We are giving the exact same permission here. Amazon EC2 full access, and click next, and giving a role name EC2 full access or something like that. So in this case it is full access role. That's the name of the role we are giving. And if you look here, there are a couple of interesting things here. What is the allow action here? STS assume role with SAML. It is not STS assume role anymore. STS assume role with SAML. And principal is federated. Now the principal is federated, which means that this particular identity provider, SAML provider, is being trusted. Whoever is signed by this particular provider. Basically, we are telling whatever signed by the private key of this guy right here, trust that. That's what being mentioned here. Line number 8. In a very cryptic manner, very indirect manner. But it's the same thing we have learned in our RSA lesson. Line number 8 is simply saying trust the public key of the SAML provider, or in this case the Entra ID public certificate. Trust that certificate. That trust is happening here. Now there is a condition, as you can see here. The policies are very fine-grained, granular in AWS. It is checking for a SAML attribute, SAML :AUD equal to this particular URL. We have seen this URL before. So it is checking for this particular URL within the SAML token. Condition string equal to SAML :AUD, this particular thing. So another condition is being checked while that user is being onboarded into this particular role. So that's the trust policy. And permission is easy to full access. No need of any special explanation for that. We have seen that left, right, and center in the lesson before. So this is the role we are having. Now, technically speaking, from a pure SAML perspective, we are done here. We are all done with the SAML configuration. So this is all we do in a typical SAML scenario. Now, in the case, this particular case, slightly different because of the different roles present in AWS. So basically, what we need is, we need a user for Azure to know all the roles available, to enumerate that role within the console of Entra ID. This is not a SAML requirement. It's an additional thing we are doing here. A very good thing actually. But it's not really a SAML thing from a pure SAML technical standpoint. Basically, we are letting Azure know what are the roles present in this account. And we are going to create a user for that. Again, nothing to do with SAML. SAML part is done. But in the configuration for this particular demo to work, we need this, what we are doing. We are going to create a user, and that user will have list permission of all the roles within this account. And from where we will use that user? We'll use that user from the Active Directory or the Microsoft Entra ID. So let's get that done. So first we are going to create a policy, and then we will attach the policy to a different user. Again, this is not directly related to SAML, but we have to do this to make this thing work. So we are going to policies. We are going to create a custom policy. In this case, we need to select IAM list roles. That is the only permission we need. Very minimalistic. List resource on all the IAM things. List a role, and it is on all resources. List all resources. This is the policy right here. And now we need to create a user. Create user. And this user we will give to the Azure Active Directory. Any name is fine as long as you remember it. We are going to name it Azure AD Service User. No need of console access. We have not given that console access. Attach policies directly. This is all we have done in the previous lesson. If you want, you can look into it. So this is the only permission this user is going to have. Next, create user. So this is the only thing the user can have. Create user. And here is a user. Now we need to get the credentials of this user. Create access key. We are going to create an access key, third-party service. So we're creating an access key so that we can access it from a different cloud provider altogether. We are just giving a description tag value. And here is our access key. I'll be deleting these access keys by the time you watch this video so that this key may not work if you're trying to use it. So I'm going to the Azure, and I'm going to the AWS Enterprise application. So I'm going to click on provisioning and get started. Automatic admin credentials. So basically, this is where we are going to enter those secrets we have seen in the AWS user credentials. Client secret. We'll copy that from the AWS. So this is the access key. Basically, we are going to provision roles, and secret is that secret token. So this is the secret token, and test connection. Testing is working, which means that now it will be able to onboard all the roles in that particular account in the Azure. That is, this was for save. So there is this thing called mapping. If you want to map to something else, not getting into the details of all these things, we are simply learning SAML, not a lot of other things. Start provisioning. So if you're wondering what is going on right now, it is reading that account. As you can see, it has read one role from the other account. Now, if you go to the application again, users and groups, add user and group. As you can see here, this role we have created right there in the AWS. As you can see, easy to full access role Azure AD. This role, it has read this role using that user we have created. Easy to full access role. That is what we have. You can try create other roles. That role will appear here if you're doing this particular demo. So in this case, I'm going to select this particular user, and there is no way to select any other roles because I don't have any other roles. Otherwise, that would have been active. Right now, only one user is selected, and that role is this particular role because that's the only role available. So basically what I have done is I have added this particular user, the user we have created in the beginning, to this particular application, which is AWS Test App. Now I'm telling the identity provider, hey identity provider, this particular user Joe, which is there in this domain dev.sourceinst.com.au, can access this application. What is this application? AWS Test App. Now, what that user has permission for, that is also I'm giving by selecting that role. I have selected that easy to full access role right here in the side of the screen. I didn't have any other option because I didn't have any other roles which has SAML provider as the trusted entity. Important thing to notice. Now what we are going to do, we are going to myapps.microsoft.com. That's where we are going. That's where the application location, all the application location. Now we need to get this user to be signed in, and that's what we are going to do. We are signing with this user. This is the user we are signing in. Look at the name of the user, joe@dev.sourcin.com.au. That is the user we are using to sign in. And where we are signing? We are signing into login.microsoftonline.com, which is the IDP in this case. So we are typing the password. It may ask you to change the password. It is indeed asking to change the password. We'll slightly change the password. You can avoid doing this by changing the configuration. In this case, we are changing the password. Sign in. Any password you can give. The current password looks to be wrong. I'm just copying the password and pasting it. Sign in, and it worked, and we are going to ask it later, and here we are. So this is the login of my apps, and we are signing in, and we got into the AWS console. As you can see here, we have got into the AWS console without any AWS IAM roles. Very important point to notice here. And as you can see here, easy to full access role. This is a role we have created for that user. And this is a user, joe@dev.sourceinst.com.au. Very important point to notice. What is the expected permission for this user? Easy to full access. Let's try that out. Now we are going to EC2. pretty much we are getting access denied and everything else. And you can try create an instance. Don't worry about creating an instance if you don't know what this is all about. Just I'm creating an instance. I'm checking the permission if this particular user has a permission. So this is the creating a VM. I'll be pretty fast on this because that's not the point of this particular demo. I'm just testing if it is really working what we have done so far. And it is indeed working. We are able to create an EC2 instance. If you want to see if this can create an S3 bucket, something else other than EC2, we should get an error. Let's try that. Create bucket, another resource. We are expecting an error. Yes, we got it. Failed to create bucket. To create a bucket, we need S3 create bucket permission. Oh, good. This is expected. This is exactly what we want. So this means that whatever we have done is working. Now, that is just a setup. Now we need to understand how this thing works. So this is just the tip of the iceberg. Now we need to reverse engineer the whole thing. To understand how it works behind the scenes, we need to get the SAML token. We need to see what is in the SAML token, all that sorts of thing using Fiddler. So if you want, you can take a break, but I'm going to continue here. In fact, you could have taken break at any point in time, but we are going to continue anyway. So pause the video if you want. We are going to reverse engineer this whole thing. So what I'm going to do is that I'm going to copy this particular URL. And again, we need to start everything from scratch in terms of authentication, not from the setup perspective, with Fiddler running. So I have Fiddler running here. What I'm going to do is that I'm going to clean that Fiddler up. So I have removed everything. So the Fiddler is not capturing anything right now. Let me make everything ready before Fiddler start capturing anything. Once it is ready, I will capture by clicking here. So I'm going to get the developer tools here so that I can reload whenever I want. I'll just move this to the extreme end. Empty cache and hard refresh is what I'm going to do. So again, it is not going to ask me any username and password, but I'm expecting a new SAML token. So due to that, I'm going to start capturing here. Here is where you stop and start capturing in Fiddler. If you click here, it'll stop and start. I hope it is capturing right now. I'm getting a couple of traffic. I'm going to do a hard refresh of this page again, assuming that it'll come again, the SAML token. Let's see if you're getting, otherwise we'll do a log on, proper log on. So looks everything is okay. What I'm going to do is I'm going to click on this particular application right here, and it is going here for the auth. Now I'm expecting some kind of SAML traffic in the Fiddler. Let's see if we are getting something. So we are completely authenticated into the console of the AWS. Now at least let's stop capturing. So for some reason I'm not seeing any traffic. So let me clean this and do it again. Sometimes you have to do it a couple of times to get the correct traffic. So I'm capturing again Fiddler. I'm going to close this and a hard refresh and click on here. Everything same. Let's see, in the Fiddler we got something. Let's stop capturing. What we are looking here is the SAML URL of AWS. Yes, this is the URL we've been looking at. Looks like it is available. The host is signin.amazon.com/SAML. It is present, and to that particular request we are passing a SAML response. Let's park it here. Now we need to understand where this thing is coming from. That is what really matters to us. So as you can see, this is that request. Just before this, we have this particular response from loginmicrosoftonline.com and all this different cryptic URL. Let's see the request and response of this. So it is a GET request with a lot of these details. And what is the response? The response is a SAML response, as you can see here. And the value is this one big thing. Let's copy this to a notepad so that we can have a quick look into it. So basically what we are looking at is the response we got from Microsoft. And it is a hidden form with an action, this particular thingy right here. And let's see the response header. It does have some cookies and things like that, but the main thing is this particular hidden SAML response, which is going to pass it to this particular URL. Now let's see if we can decode this thing. So there are tools to decode SAML responses. So let's see if we can get one of those tools and decode these things and make something out of it. Copy. I have copied that response. And I'm going to search for SAML decoders, SAML response decoder. As you can see, all these identity provider applications are coming into the picture. Okta, Ping, all the names we talked so far. Let's see how Ping works. Let's see if we can use Ping to decode this thing. Decode. Looks like it is able to decode. I don't know why it is named as request, but it is a response. Probably it's all the same encoding format. Invalid code length set, but I think we are getting what we need. Let's copy this thing. It's an XML, but it is, at the end of the day, it's a base 64 encoded. We have already discussed about base 64. It's just an encoding, text encoding at the end of the day. So it doesn't matter whether it's response or request. Let me see how I can copy this. Copying this, Control A, Control V. So I'm putting it into 1.xml. I will share this particular file with you in case if you want to have a look. So this is that file. I'm going to open up that file inside a web browser. And this is the SAML response we are looking at. So this is the information we got after we have given our precious username and password to login.microsoft.com. Very important to understand. We have given some secret, precious username and password, OTP, whatnot, and we got this thing. And what is this thing? This is the SAML response. Now, you can look at a lot of things in that response. Signature value is very important. Signature value is there. Certificate is there. You can look at the certificate, but signature value probably the single most important thing. Signed document, which means that any modification in this particular document right here you're looking at, for example, I have changed this to joe1@dev.sourcesense.com or something different. This signature is gonna fail because this document has been checksummed and signed using this signature, using the private key of this corresponding public key. This public key can be used to verify the signature, provided you trust this public key. We have done a lot of things to make sure that AWS trust this particular public key. Everything boils down to the same basics. Same basics we have learned in the previous lesson. Now, what are the things it is signing? Attributes, so many attributes. These are called SAML attributes. You can have any number of attributes. What matters to us? The attribute name, claims.name, claims.role. Everything starts with claim is an important thing. So this SAML response is claiming the role of this particular user. This is the role of this particular user. This is the identity provider. And this is the username. Two very important information, the role and the user. And there are repetition of the same things here and there, but ultimately it has 1, 2, and 3 most important things. There are a lot of other things which validates and helps to decrypt all these things and verify everything, the SAML version and things like that. But at the end of the day, this is what we are getting from Microsoft, the identity provider here. Now what we are going to do with this thing, we are going to push that to this URL right here. Where is that? This one right here. So we got this in the response. This bottom part is the response. Now we need to push this thing in the request. So on the top is the request. So let's do a text view. It's very difficult to decrypt. So this is the response. Probably a web form will give us better. Yes, the web form is giving us a better view. At the end of the day, this is all view of the same thing. You can do XML, you can do JSON, you can do raw. Raw is pretty raw, as you can see here, SAML response at the end of the day. And we are passing that SAML response right here. If you want, you can verify, but it's going to be the same thing, otherwise it won't work. And we are passing it to signin.aws.amazon.com/SAML. This is a URL we have seen sometime back. And once that is done, you get a 200 back and the rest of the pages and things like that. Probably a redirection, doesn't matter. In this case, it is a redirecting to the correct page. But by that time, we have set up all the cookies and all after the auth. Auth is successful, and now onwards, normal communication using the cookies, just like we have seen in the case of Gmail. So the important part is we are getting the SAML from here and we are pushing it here. My apologies. We are getting the SAML from here and we are pushing it here. So that's what we've been discussing so far. Now let's review what we have seen so far within the console of both AWS and Azure. So first we have done is we have created a user called Joe. So this is the user Joe, and Joe is part of this particular domain. So we are yet to see how to onboard a domain. I'll show you shortly. That's the last part of our demo. We have created this particular user, and then we have created the applications. So these are the enterprise applications present, and this is the AWS test app we have created. So if you go to Microsoft Entra ID, you can go to manage, then enterprise application, and then if you click here, you will get to see a little more details of the application. So this is where you manage the application, and we have set up the single sign-on for that particular application. So there are a couple of different things here. Single sign-on, we have done that, and we have changed a couple of things. We have added a one here. Other than that, I don't think we have made much of a change. Relay state, logout URL, sign-on URL, all these different things we have not touched. The other things we pretty much took the default because it's AWS, Microsoft knows about it. And one of the things we have not done is looking at this particular certificate. So this is the certificate which will be signing the token. So this certificate was there pretty much all over the place, but we can download it like this and have a look. So this is the certificate, the public key pretty much, and it is not really trusted by us. This CA root certificate is not trusted because it is not in the trust root, which means this particular root certificate is not trusted by this particular machine. But it worked in AWS because we have imported that identity provider. So we have asked to trust this particular certificate. Couple of details other than that. The login URL, login.microsoft. Login URL for this particular app. Microsoft Entra identifier. So that is this. Logout URL. All these different URLs are there. Doesn't matter to us much. Now, what are the users for this particular application? The user is Joe. We have added that user to this particular application. Right now, this user we are seeing is in the application, not in the other users. For example, you can have n number of users and only one user has permission for this particular application. Now, in the provisioning, we have looked at one role it found out, and we got the roles. These are the two roles we got, and we assigned Joe to that particular role right here. We have discussed that roles in AWS came into Azure because of the additional user we have created with the list role permission. Now let's have a look at the counterparts in the AWS account. So to see everything, we need to log into AWS root console. Let's do that. So we have logged into AWS with the admin credentials, root credentials. So it is imposing the MFA for root, which is very good to have. We'll have to set up MFA in 3 days, which is fine. So if I go to IAM, I'll see the identity provider, which is the Azure AD. So we have imported that metadata, some of the items in the metadata is here, but not everything is here, especially the certificate to trust and things like that. But in the XML format, you have more information about the metadata. Now, roles, we have created the role. This is the role we have created, and permission is easy to full access. No confusion there. And we have seen this particular thing right here, SAML AUD. So this is the trust relationship, which has the federated ARN towards the SAML provider. And there is some additional condition as well with SCS assume role with SAML. And then that final user, the one we created, Azure AD service user, which has a list policy. This is how we listed policies from that Azure account. Very important. Basically, this is not very much related to SAML in general. There is a mechanism Azure should have to understand what are the different roles available within the AWS. So one of the things is there are so many other roles. Why these other roles are not coming up? So Azure is displaying only roles which has the identity provider as Azure. All the other roles have different identity providers, or it is not trusted. Basically, this is the reason why this role is the only role which is popping up in Azure. You can create more roles and re-provision in Azure and it'll appear there. So we have that user, which is this, and we have that policy. This is the policy IAM list all resource, basically list roles. That is the policy we are having. So this is the list roles on all resources allow. For this particular user, there is no console access, and there is already a key. This is a key we are using from Azure to obtain that particular policy through this user to enumerate all the required roles. So to conclude, we have seen what is SAML and we have implemented a proper SAML implementation using AWS and Azure. If you want, you can try the demo yourself. It's not that hard, although you need a lot of account setups and things like that. But all in all, we have understood the concept of SAML. Next is OIDC, which is very similar to SAML, and we'll be covering that in the subsequent lessons. Thank you for watching. I'll see you in the next.